Hi, welcome to our video. Today I'll be explaining the A search algorithm. I want to start by asking a quick question. Have you ever used Google Maps in India and found yourself in a tiny alley where even autos can't fit? Well, that's because it guarantees finding the shortest and fastest route to your destination no matter what. That's basically what the A search algorithm is. Next, we're going to break it down in a way that's simple, practical, and actually worth remembering. The A star algorithm is a pathfinding algorithm that helps to find the shortest path from the start point to the goal. It works by balancing two key things. One is the g of n, another is the h of n. So, the g of n is the actual cost from the start node to the current node. Think of this as how far you've already walked or the total distance you've traveled so far. And h of n is the heuristic estimate of the cost to reach the goal from the current node. A heuristic is basically a smart guess of how far you still have to go. For example, on a map, it could be the straight line distance to your destination. Then A star combines these using a magic formula. F of n is equal to g of n plus h of n. This means A star doesn't just randomly guess a path, but it doesn't try every possible path either, like brute force search. It's strategic. It always expands the node that looks most promising based on both the distance traveled so far and the estimate distance to the goal. It's like now that we know how A star works, let's see it in action with a graph example. Our goal is to reach node G from node A. Here's the graph. So these are the edges, the real distance you actually travel, and the numbers are called as weights, which represents the actual cost to travel from one node to the next. Here we can see that from A to B, the weight is 4, so it costs 4 to go from A to B. From earlier, if you can recall, we said that g of n is the total cost from the start node to the current node. So for this example, we calculate it by summing the edge weights along the path taken. For example, if you go from A to C, the g of C is 2. Next comes heuristics, which, as you know, the estimate of the remaining cost to reach the goal from a node. Remember, it is not the real distance, just a smart guess to guide the algorithm. In our example, h of A is equal to 7, meaning from A to G, I estimate it will cost 7 units. Heuristics help prioritize which node looks promising to expand next. Let's run A star on this graph and see how it finds the shortest path. First, step 1, let's start at A. We'll use the formula we've seen earlier, that is f of A is equal to g of A plus h of A. So here g of A is equal to 0, meaning like for A there is no given value, and h of A is equal to 7 because 6 plus 4 equals 7, and finally 0 plus 7 is equal to 7. Now we expand A's neighbors. B, C and D, those are A's neighbors. So first we'll see about B. So G is equal to 4 here, and f of B is equal to 4 plus 6, which is 10. And next we'll go with C, and G of C is 2, and then f of C is 2 plus 4, which is 6. And then next we'll go with D. And for g of D is 5, and f of D is 2 plus 5, which is 7. We now pick C because it has a lowest value, which is f is equal to 6. From C we can reach to F. Here again G is we calculate G and F, and we get 10 and 13. Now we compare the open nodes. B, f is equal to 10, and for D, f is equal to 7, and for F, the f is equal to 13. So the lowest here will be 7. D, f is equal to 7. So from D, we reach our goal to G. G is equal to 7, f is equal to 7 plus 0, which is equal to 7. So the optimal path is A to D and D to G. with a total cost of 7. That's our shortest path. Notice how A star chooses the path strategically. It never just guesses and it guarantees the shortest route. Now, the real question is why A star is so powerful? Well, that's because it's both complete and optimal. Um, Complete meaning if a path exists, A star will find it. And optimal, that is, if your heuristic is admissible, meaning it never overestimates the actual cost, A star will always find the best path. But there's one catch: if the heuristic ever overestimates, A star might know. Now, the real question is why A star is so powerful? Well, that's because it's both complete and optimal. Um, Complete meaning if a path exists, A star will find it. And optimal, that is, if your heuristic is admissible, meaning it never overestimates the actual cost, A star will always find the best path.